Okay, this is Statistical Rethinking, second edition. We're in chapter 16, and we're on the medium question 16M3. Okay, here's the question. So we're going to use prior predictive simulations to investigate the lynx-hare model that's presented earlier in the chapter. We'll begin with priors that are presented in the chapter and look at what this suggests about the population dynamics, and then try to make improvements. Okay, so the first thing I'm doing is just pulling up the data here, and I'm calling it D, although I don't actually think that's important. I just did it anyway. So the first thing I'm going to do is just rebuild this function that was given to us in the chapter here. So this is really just copy-paste from earlier in the chapter. And let's make it a little prettier, maybe. So we've run that, or I guess I'll run that. And then I'm just going to start with the example that's given in the chapter here. Okay, so to demonstrate how this function works, the chapter gives exactly this example right here. Okay, and we get this dynamic right here, where the hares, I believe, are the black line, and the lynx are the blue line, right? And you can see that they kind of work together, or they move together across time. Okay, so hopefully you're familiar with the lynx-hare model in the chapter, so that makes sense to you. But this is not, these values right here. First of all, they're not prior. I mean, I guess you could say that they're priors, but they're, there's no probability associated with them. They're just constants here. So what we have here really doesn't represent a prior distribution as such. It represents one instance of, of these dynamics here. So what we actually want to do is to look at the model that was presented in the chapter, and then look at those priors, and then simulate those. So now, normally the way that you might do this is, you might just look in the chapter for the model, but it's not made explicit, and instead it's part of the rethinking package. It's called lynx-hare model. But when you go to look at lynx-hare model, at least in the Colab bit here, you just get this. You could sit here and try to parse this and try to make sense of it, but what I did is I just asked ChatGPT to reformat that in something that looks familiar, and so you get this. If you scroll all the way down, you get to the priors right here. Okay, so here's the priors. For theta 1 and 3, they look the same, and then theta 2 and 4 look like this. Okay. So I've just highlighted what the priors are here. So first, let's simulate what these priors look like, right? So I have my theta values, which are informing the model here. Okay. And when we make some tweaks to the plotting, which was quite a bit of trial and error, but just look at this code and you can kind of see how it worked. We get these types of dynamics right here, where basically both populations just crash to zero, or that's what's expected to happen in the prior. Now, this is only 9 simulations. We maybe could have done this, with any arbitrary number of prior simulations, but 9 out of 9 really suggests something crazy is happening. Actually, let me, just to be sure, let's run X out a long ways. Okay, that's not good. All right. Never mind that. And I've broken it. Hold on. Okay, we're back. All right. So we want to adjust, the priors that are used in that in the model. Again, the model being what we had to kind of parse out from the lynx-hare model object in the rethinking package. And so all I'm going to do, so I'm going to tweak these priors, and I'm just going to put them more in line with what we saw up here with the with the one instance example. Okay, and so that's all I've done. I've just adjusted the priors to look more like that, but put them into a probability distribution. Okay, and when we run that, we get these types of dynamics, which maybe ourselves not being biologists or ecologists or whatever, You know, maybe we expect this or maybe we don't, but the book certainly leads us to believe that this is what we should expect to see. So anyway, that is 16M.